Hello students, myself R.D. Mahajan, Assistant Professor, Marathwada Institute of Technology, Aurangabad, presenting my video on the topic Taylor's Theorem for function of two variables. Let us see the statement of that theorem. Taylor's series of f of xy about point x minus a and y minus b is given by. Therefore, f of xy is equals to f of ab plus x minus a into fx at ab plus y minus b fy at ab plus 1 by 2 factorial into in bracket x minus a bracket square fx f double x at ab plus 2 times x minus a y minus b f of xy f xy at ab plus y minus b whole square f double y at ab. All this suffix stands for the derivative. Fx means the dou f by dou x, first order derivative of f with respect to x. Fy means dou f by dou y. F double x means dou 2f by dou x square. Fxy means dou 2f by dou x dou y, and fyy means dou 2f by dou y square. I will explain by solving two simple examples. First one, expand f of xy is equals to x raised to y as far as second degree. We can extend this up to infinity. Therefore, if we take up to this, we can get the expansion up to degree 2 in the powers of x minus 1 and y minus 1 using Taylor's theorem. Therefore, this is the function for which we require to find the Taylor series expansion and about the point a, b. Therefore, comparing this x minus 1 with x minus a, we get therefore as 1. And the second one, y minus 1 is equals to y minus b. This gives you b is equals to 1. Therefore, these are the values of a and b about which we require to find the expansion. Then here given f of xy, function of two variables, and that function is here x raised to y. And as it is function of two independent variables, whatever the derivatives we are getting, all are partial derivatives. Therefore, we require to find this all derivative. Therefore, first of all, we find fx. At fx means this dou f by dou x of this function. Therefore, differentiating this with respect to x, keeping y constant, therefore it is x raised to n type of term. Its derivative is y x raised to y minus 1. Derivative with respect to x. Again differentiating it with respect to x, y constant, derivative of this term with respect to x is y minus 1 x raised to y minus 1 means y minus 2. Okay. Then differentiating with respect to y, keeping x constant, derivative of this with respect to y, keeping x constant, it is a raised to x type of term. Its derivative is a raised to x into log a. Therefore, here the derivative of this term with respect to y is x raised to y into log a, log of x. Standard result of derivative. Then again differentiating with respect to y. Therefore, log x is constant with respect to x. we take the derivative of x raised to y with respect to y. Its derivative is x raised to y into again log x, and therefore it is log x bracket square into x raised to y. And differentiating this with respect to y or this with respect to x, we get fxy as I will differentiate this with respect to y. Here it is y, here it is y. Therefore, applying product rule, first term as it is, derivative of this with respect to y, it is x raised to y minus 1 into log x plus second term as it is, that second term is x raised to y minus 1 and derivative of y with respect to y 1. Okay, and therefore we can take x raised to y minus 1 common from this 2. Here remains 1 plus y log of x. Okay, and then we find the values at 1 1. Therefore, f at 1 1 means when a is 1, b is 1, we get, replacing x by 1, y by 1, 1 raised to 1, we get that value as 1. Then fx at 1 1, put x and y as 1 1, therefore here it is 1, y is 1 raised to 1 minus 1, 1 minus 1 is 0, 1 raised to 0 is 1, 1 into 1 we get 1. Then fxx at 1 1 is equals to, put the value of y as 1, 1 minus 1 we get 0, 1 raised to anything is 1, 1 into 1, 1 into 0, we get that value as 0. Then fy at 1 1 is equals to, 1 raised to 1, we get 1, and log 1, as log 1 is 0, this term becomes 0. Okay. Then fyy at 1 1, log 1 square, log 1 is 0, therefore that term becomes 0. Okay. Then fxy at 1 1, here it is log 1 0, therefore that term becomes 0. Okay, we calculate here from this, 1 raised to 0, 1 raised to 0 is 1, 1 plus y is 1, log 1 is 0, and therefore we get that value as 1. Therefore values are 1 1 0 0 and 1. Okay, and therefore substituting these values in Taylor series, therefore Taylor series becomes, therefore that f of xy is here, x raised to y, f at ab, f at 1 1 is 1, plus x minus a, x minus 1, fx again 1, plus y minus b, y minus b, y minus 1, fy, fy is 0, therefore this term becomes 0, plus 1 by 2 factorial into x minus a, x minus 1 bracket square, f double x is 0, therefore that term again becomes 0, plus fxy, therefore here it is 2 x minus 1 y minus 1 into fxy, the value of fxy is 1, plus y minus b, fyy, that term is 0, plus so on. And therefore if you simplify it, we get that series as 1 first term, plus x minus 1 into 1, we get x minus 1, plus this one is 0, plus 1 by 2 factorial, this becomes 0, we get 2 times x minus 1 y minus 1, this one is 0, and plus so on. Therefore this is the required Taylor series up to second order for that given function using this result. Second example, expand in Taylor series. Expand in Taylor series for f of xy is equals to e raised to x into cos y, e raised to x into cos y in the powers of x minus 1 and y minus pi by 4. Again up to second order. Solution, here comparing that x minus 1 with x minus a, it gives you a is equals to 1, and second y minus pi by 4 with y minus b, it gives you b is equals to pi by 4. These are the values of a and b. Second, f of xy is equals to e raised to x into cos y. Therefore differentiating it with respect to x, keeping y constant, therefore cos y constant, derivative of e raised to x is e raised to x, therefore we get e raised to x cos y. Okay. Then differentiating this with respect to y, keeping x constant, therefore e raised to x is constant term, Derivative of cos y is minus sin y. Therefore, we get this one. Finding fy means partial derivative of this with respect to y, keeping x constant. Therefore, e raised to x is constant term. Derivative of cos y is minus sin y. Again, differentiating this with respect to x means second order derivative of this with respect to x. Cos y constant. Derivative of e raised to x is e raised to x. We get e raised to x cos y. Fyy, second order derivative of this with respect to y. Therefore, again differentiating this with respect to y, minus e raised to x. Derivative of sin y is cos y. Therefore, these are the required derivatives. Try to get the values at a, 1, b, pi by 4. Means replacing x by 1, y by pi by 4. Therefore, e raised to 1 cos of pi by 4. The value of cos of pi by 4 is 1 by root 2 cos 45. Therefore, it is 1 by root 2 into e, or e by root 2. Then fx at 1 pi by 4. Again e raised to 1 e cos of pi by 4. Cos pi by 4 is again 1 by root 2 into e. Then fxy at 1 pi by 4 minus e raised to 1, that is e, sin of pi by 4. Therefore, minus e by root 2. Fy at 1 pi by 4. Same term, therefore minus e by root 2. Same value as these two are same. Then fxx at 1 pi by 4 e raised to 1 e and cos of pi by 4. Cos of pi by 4. Therefore, it is e by root 2 once again. And lastly, fyy at 1 pi by 4. It is minus e raised to 1 is e cos of pi by 4. And therefore, it is minus e by root 2. Therefore, these are the values. Substituting these values in this Taylor series result, we get, therefore, f of xy is e raised to x into cos y is equals to right hand side term f at ab, f at this ab, e by root 2 plus x minus a, x minus 1 into fx. Fx is e by root 2 plus y minus b, y minus pi by 4 into fy. The value of fy is minus e by root 2 plus 1 by 2 factorial x minus a bracket square, x minus 1 bracket square, f double x. The value of f double x is e by root 2 plus 2 times x minus a, x minus 1, y minus b, y minus pi by 4, fxy, the value of fxy is minus e by root 2 plus y minus b, y minus pi by 4 bracket square into f double y, the value of f double y is minus e by root 2 and so on. Find it, we get this is equals to we can take e by root 2 as a common throughout. Therefore, when we take a common from all, here it is 1 remains, plus here x minus 1 remains, here it is minus y minus pi by 4, okay, here it is plus 1 by 2 factorial here remains x minus 1 bracket square 2 times x minus 1 y minus pi by 4 plus here it become minus when we are taking this also become minus, therefore middle sign is here minus, here also minus y minus pi by 4 bracket square bracket close, this bracket close, and then we close this curly bracket and plus so on. This is the required Taylor series. Therefore, with the help of these two examples, I have explained how we can obtain the Taylor series for function of two independent variables using this formula. If you are watching my videos, please like and share it, as well as subscribe to my channel. Thank you.